Assalamualaikum, my name is Syazana Aliaa and I am going to present to you my final year project based on Mohd 2, a review of polyhydroxycanoids PHA production from palm oil mill effluent and its application in nanotechnology. As we all know, Malaysia is the world's top producers and exporters of palm oil supplies. Our country has many palm oil plantations, which is something we're familiar with. However, the biggest concern in the palm oil mill effluent, or called as POME, contributed up to 60% total waste generated. Therefore, researchers decided to convert POME into PHA. But how is it going to happen? Well, at the mill, palm fruit undergo milling process in order to separate functional components and the excess of wastewater. Palm oil is extracted from milling process and the wastewater is going through sludge acclimatization to produce activated sludge. The PHA was carried out initially in the bioreactor by batch and fed batch fermentation. This is to increase the PHA productivity level, and the culture must be in the high density of large-scale production. These technologies will help cities in managing waste in a more sustainable and cost-efficient way. In the figure stated, general application of bioplastic PHA in the three most common industry, which is material industry, medical industry, and lastly the fuels industry. The usage of petrochemical plastic can cause harm to health and environment. For an instance, methane gas from anaerobic fermentation method of POME will pollute the atmosphere and wastewater. Also, lack of biological polymer for nano-based material has hindered for the potential application and advance of biotechnology work. Polyhydroxycanoids is a microbial storage polyester that can be synthesized naturally by most of the bacteria. Moreover, this discovery of new potential biodegradable plastic display an alternative ways of cost-effective and safer products. Wastewater treatment plant can be achieved with the use of PHA production. Thus, PHA nanomaterial upgrades or changes the remedial discovery, treatment, and prevention of disease in the cellular level. Eventually, PHA is a cheap and renewable carbon feedstock for efficient conversion. In this review, we analyze and investigate whether PHA polymers face some research gaps and questions. First, POME productivity when using waste streams is actually their diluted nature, as these effluent are provided as in feed in the fed batch PHA accumulation, which provoke the substantial increase in the bioreactor operating volume, thus reducing the productivity level. Nevertheless, strict requirement for sterile fermentation condition is required where there is an insufficient of production facilities which limit the exploit of PHA in quality and quantity. There are three main objectives of this review. First is to review the application of palm oil effluent in the PHA production via batch fermentation. Second is to discuss the potential of palm oil mill effluent as a cheap and reliable carbon source. Lastly is to see the application of PHA nanomaterial in biomedical industry. Based on a journal by Kumaran, PHA is a natural biopolyester polymers which need to be synthesized by specific bacteria. Examples of biopolymers are cytosine, polylactic acid, and polyhydroxybutyrate. PHAs can be grouped according to the length of the carbon chains, such as short chain length (SCL), which contain 3 to 5 carbons, medium chain length 6 to 14 carbons, and SCL, MCL combined PHAs. As you can see, these are the examples of PHA production by various bacteria and its carbon source. This info is based on the ready research paper. What is POME? Well, POME is generated during palm oil extraction process and abundantly available. It is a great potential source for biomethane production and controlled by microbiodegradation, which is rich in organic carbon, nitrogen, and minerals. This flowchart shows palm oil mill effluent being pre-treated by anaerobic bioreactor and produce volatile fatty acid. Then, PHA accumulate in a high quantity along with the help of PHA production reactor. Also, there is a flowchart shows excess sludge undergo fat batch fermentation in order to produce PHA extraction. Nutrients give impact on higher PHA productivity level. These are the examples of biopolymer used in a nanomaterial. Syazana is a natural polymer which applied in a drug delivery in Alzheimer's disease, where it is appeared as a biodegradable and stable transportation for delivery towards central nervous system medication and appropriate for CNS targeting. Alginate is applied in a delivery of drugs and protein, while hyaluronic acid is applied in a long-term delivery of peptides, wound dressing, and synthetic bone graft. This is the design of polymeric nanoparticle synthesis based on a journal by Kim in 2018. The techniques for synthesis of polymeric PHA includes solution casting, electrospinning, and 3D printing, which then depends on the application of PHA nanomaterial in specific biomedical areas such as cardiac patch, drug delivery, and etc. To summarize, polymer is a potential substrate for the production of PHA, as it is generated during the process of sterilization of palm fresh fruit bunches, clarification of palm oil effluent, and effluent from hydrocyclone operation. Polymer undergo anaerobic treatment for PHA production by specific photosynthetic bacteria. Also, polymer nanomaterial represent largest and most versatile class of biomaterials in utilization of biomedical fields, specifically drug delivery system. Most importantly, PHA degradation products characterization is where it does not employ any negative and toxicity effect to the living cells or tissue of living things. Great progress has been made in the understanding of structure and production of PHA. The use of cell cycling system coupled to fat batch processes is a promising way, and reactor design preventing the cells from escaping the system, while allowing supernatant removal could result in high cell density and reduced reactor volumes. The production of PHA polymers is independent of fossil resources, other than less energy-intensive methods such as forward osmosis. Membrane could also likely to be applied. Biopolymer does not employ any negative or toxicity effect to the living cells, tissues of the human or animal. Blending two different types of PHA or PHAs with synthetic or other natural polymers have generated novel biomaterials to suit specific biomedical applications. Well, that brings us to the end of my presentation. Thank you so much for your attention and hope we can get positive input from this review. Thank you.